All right, let's take a look at chapter 6. In the other class, we got through about half of chapter 7. We did 6 and 7. So I will try, I don't know, since we did the book thing, I don't know if we'll be able to even get that far. But let's do it. Here we go. It says, find the sum of the measures of the interior angles of a convex hexagon. Lots of words in there, lots of geometry words. But it's actually a lot easier. You're not going to take notes on this? It'd be a lot easier. And why do you need your phone out? Put your phone away. All right? Take some notes on this. All right? You're just going to sit there and stare off into oblivion. Take some notes, and maybe that'll help you do well on this final. All right? So find the sum of the measures. Did I check you off the list? Okay. All right, of a convex hexagon. So what is a hexagon? How many sides is a hexagon? It's a pentagon. 6. Maybe I should make Mario take the final for that kind of answer. All right, so it's 6. All right, so there's a little formula, and it's been a long time since we've done this, but here it is. It's n minus 2 times 180. Do you remember that? Yeah, it's something that we use quite a bit. I'm going to put it in a little box. All the stuff's in boxes are important, so we're going to put that in a box. Tell you what, let's zoom this in just a little bit. All right, so what does that mean, n minus 2? What's the n? How many what? It's a hexagon. How many sides we have? That's right. So it's a hexagon. How many sides? 6 sides. So what do I do with this? 6 minus 2. All right, times 180. It's as easy as that. All right, yeah, so it's just 4 times 180. 4 times 180. Let's see, 2 times that is 360. Double it again, 720. So that's the sum, right? It's in caps. It's the sum of all the interior angles on a hexagon. That means when you add up all the angles, it doesn't have to be in a regular hexagon. If you just have any 6-sided figure, if you add up all the angles, you're always going to get 720 degrees. Doesn't matter what the shape is. It's got to be convex. We won't worry about that. All right, what about this one? Find each interior angle in a regular what? Octagon. How many sides does an octagon have? It's got 8. All right, you got to know those. I could change the numbers. I could make that a pentagon. I could make that an octagon. I could make it a decagon, right? Any of the sides that we've talked about, you got to know what those words mean, all right? So how do I do each interior angle? And this is a regular octagon, which means what? All the angles are equal and all the sides are equal, all right? So the important thing is all the angles are equal. How do I find each? Not all of them together, just every single angle in there are going to be the same. What is each going to be? Well, you're going to do this. You're going to start off using this formula again, but this time it's an octagon. So what are we going to do? 8 minus 2 times 180. And then we're going to find each angle, and all the angles are exactly the same. So what can we do? Divide the sum of the angles by how many angles we have. And if there's 8 sides, there's 8 angles. All right? 8 minus 2 is 6. Times 180, whatever that is, divided by 8, and that becomes 135. And there you go. That's how you do it. That's number 1. That's number 2. Make sense? Yeah. Pretty easy. It's coming back to you now, isn't it? Find the length of each side of a rhombus. First of all, what does it mean to be a rhombus? How many sides does a rhombus have? How many sides does a rhombus have? 4 sides. What's true about all 4 sides? They're all equal to each other. That's what a rhombus is. There you go. There's your rhombus right there. Okay? So all 4 sides are equal to each other, which means what's true about this side and this side? They're equal to each other. So we want to find the length of all the sides. Before we find the length, we need to find what x is equal to. So how do we solve for x? Set them equal. Very good. All right, so 3x minus 9 is equal to what? 2x minus 4. Let's do the math. Let's do a little bit in our head. Subtract 2x from both sides, you get x. Add a 9 to both sides. What's that? That's a 5. Is that my answer? Do I circle 5? No, because I got to find the length of each side. So I can take that 5, plug it in. 2 times 5 is 10, minus 4 is 6. So the length of this side is 6. In fact, it's a rhombus, so the length of all of the sides are 6. Okay? Got it? Okay. Okay, this is an easy one. No math involved. Angle P, right there. First of all, this is a right angle, that's a right angle. We have a theorem, I'm not going to get into it, but there's a theorem that says if this connects two sides and they're both right angles, that means these are both parallel to each other. So if these are parallel to each other, what do I know about these two angles? They're both equal. What's the reason? You don't have to do that on the test. Alternate interior angles. Very good. They're alternate interior angles. And alternate interior angles are equal to each other when you have parallel lines. Okay? Let's go on. No reason to talk about that anymore, right? Now we're using this picture over here. All right? It says find the measure. Couldn't have done that before when we were going through all that nonsense. All right, let's see, what are we doing? Find each measure. So we're finding NL. Where's NL? It's this little bit right there. So how in the world do we find that? Well, this is a what? Parallelogram, right? And, oh, I was going to say, they didn't tell you enough. I forgot about this. They tell you this as well, don't they? Everybody see that? That's important. Okay, they tell you JL. JL is from here to here. And how long is that? That's 6. What are we trying to find? Half of it. That's right, because on a parallelogram, the diagonals bisect each other. So that whole thing is 6. What's this little bit then? It's just 3. All right? Super easy. That's equal to 3. What about KM? Where's K? Right here. Let's do that in a different color. Go with this blue. So KM, I got to find that whole entire thing. So how do I find that whole blue one right there? Well, they tell me what? They tell me half of it, don't they? All right, so if that's 3.8, what's this KN? That's 3.8, so what's the whole thing? Just add them up, right? Or multiply by 2. You might be able to just do that in your head a little easier, and that is 7.6. So that's what that is, 7.6. Okay? Pretty easy, just got to remember the diagonals bisect each other on a parallelogram. Let's go to this. What's this nonsense over here? Well, it's not nonsense, is it? Let's go back to red. Find AD. Where is AD? AD goes from here all the way to there. So that's what we're trying to find. Okay? But what do they tell you? They tell you BC is 2. Let's blow this up a little bit. A little easier to read. Okay, BC is 2, so that little bit is 2. And we got to find AD, that whole red one right there. Well, how am I going to find that? Because I don't know what that one is, I don't know what that one is. But we have a theorem. All right, when you got parallel lines, and if you have one segment that intersects them, and if this, and this are equal, that means that this, and this are equal to each other. Remember that? Yeah, we didn't do that too much, but we did. So if that's 2, what's this little bit AB? That's 2. What's CD? That's 2. So what is AD, the whole thing from here to here? 2 plus 2 plus 2 is 6. So AD is 6. The math is easy. Hasn't it really almost, not all the time, okay, but almost all the time been pretty easy, the math part of it, of geometry? Yeah, I think so. You just got to know what to put in, what to set equal, right? What adds up to what? That's the geometry part. The arithmetic, I don't think was that hard. None of this arithmetic was hard. None of this was hard. Would you agree? All right, let's do this one. Find WZ. It's kind of the same thing. WZ. So that's what we're trying to find, that length right there. What do they tell you, though? They tell you xz is 6. So that means from here to here is 6. And we got to find the whole entire thing. Well, they don't just tell you one of them, but you do know that this one and this one are equal. So if that whole thing is 6, what's this little bit right here? That's got to be 3. What's this little bit? 3. What's this little bit? 3. So what are we trying to find? We're trying to find just from x to z, from here to here. I'm sorry. That's what they gave you. WZ, from here all the way to there. So what is it? 6, 6, or 3, 3, and 3 is 9, so WZ is 9. Yeah, not that bad. Mario, what'd you say about me saying stuff that's easy?
Under your teaching.
Under my teaching, it's easy? Yeah. It's not because of my teaching, it's because it's not that hard. It's really not. All right. Let's see. Angle 1 is what we're trying to find right there. So this is a rectangle. So if it's a rectangle, that must mean that this and this are parallel. Why did I care about that being parallel? Because, again, we did this earlier, didn't we? This angle right here and this angle right here are equal to each other. So no math involved. What's angle 1? 35 degrees. Okay? So that angle is 35 degrees. That was easy. The next one, you got to think a little bit. All right? This one's not quite as easy. Okay? So angle 2. So I want to find, let's do that in a different color. I want to find this angle right there. What am I going to do there? Well, I know this is 35 degrees, correct? Look at this triangle. Do you see this top triangle right here? Yes? A, B, whatever that is, right there. This side is equal to this side. So this angle, what? Is equal to this angle. So what's that angle right there? It's 35. Now, they don't ask you that angle, but you had to figure that angle out to do angle 2, though. So now, these 3 add up to what? 180, right? So 35 and 35 is 70. Take that away from 180, and what do you get? 110, and that's what angle 2 is. 110. Make sense? Yeah. Okay, once you found that angle, you're like, oh, okay. Well, how did I know to find that angle? I mean, that's a good question, right? I just got to look around and say, what else can I find? What else can I find to help me find angle 2? Well, I saw that this side and this side were equal to each other. I already know this one, right? So that's got to be the same thing. You're like, oh, okay, now I get it. That's a triangle. They add up to 180. All right, enough of that. Let's keep going. We got this thing over here. What do they ask for? Angle EFG. So let's mark angle EFG. It's this big angle right there. And they also ask you to find angle 3, I think. Don't they? Yep, angle 3. All right, here's all the information they give you. Well, this is a rhombus. There's something else we know about a rhombus. The diagonals, they bisect each other, but they do a little bit more than that. They make it a 90 degree, they meet at a 90 degree angle, right? They're perpendicular, okay? So that's a right angle. So watch, if this is 60 and this is 90, what's, not the whole thing, but what's that little angle right there going to be? That's going to be 30, okay? Now we also have a thing that says on a rhombus that the diagonals bisect the opposite angles. So if that's 30, what's this little angle right here going to be? That's also going to be 30. So what are we trying to find? That whole big angle. That's easy now. Once you got that 30 and that 30, then the whole thing is what? Is 60. So that whole thing is 60 degrees. Make sense? All right. What number was that? Yep. Here's another way, or here's what else we have to find. We have to find angle 3. And if you, I did this another way in the last class, but I just thought about it. I'm like, oh, there's a lot easier way to do this. Remember what I just said about that diagonal? It bisects that angle, all right? And the opposite angles on a rhombus are going to be equal to each other, all right? So that whole thing is 60. So if that whole thing is 60, what's that? It's half of it, which is 30, okay? It's the same as these two, right? These two and these two are equal to each other. Josh is not here today. All right, everybody got that? Yeah, easy, easy. But you got to know stuff about parallelograms and rhombuses, rhombi, okay, and all that kind of thing. All right, we got 11 and 12, now 13. This says, find the values of x and y that ensures the quadrilateral is a parallelogram. What does that mean? They don't tell you it's a parallelogram, but they say, tell me what x should equal and what y should equal in order to make it a parallelogram, all right? So what are we going to do? Solve for x, correct? And so in order for this to be a parallelogram, what must be true about these two sides, the lengths of those two sides? They got to be, the fact that they're parallel, that's true, but that's not going to help us find the lengths of the sides though, all right? But we also know that the side lengths are equal to each other, all right? So this and this are equal. So guess what we're going to do? We're going to do a little math, set them equal, solve for x, and that's all we got to do. We don't have to plug it in, do we? We just have to find the values of x and y. All right, so let's do it. So 7x minus 24 equals 3x. Let's do the math, a little math in our head. Subtract a 3x from both sides. That's going to give us a 4x. Add a 24 to both sides. It's going to give me a 24. Divide both sides by 4, so x is 6. And that's all you had to do. You didn't even have to plug it in. All right, you just find what x is. And now do the same thing for y. All right, let's do that. I always like to take the bigger number and put it on the left, all right, when you're solving for x or y. You don't have to. It just makes it a little nicer, I think. So 7y equals 2y plus 5. Subtract 2y, that gives me 5y equals 5. Divide both sides by 5, y is 1. I'm going through this quickly because we've done this 100, 200, 300 times maybe, who knows, in this class this year, doing this kind of algebra. And there you go. There's your answer. Just for the sake of time, well, I'll set it up. Yeah, let's just do it. All right, this time we have diagonals. All right, we didn't have that on this one. On this one, we had the lengths of the sides. This time we have the lengths of the diagonals. So we got to know something about the diagonals of a parallelogram. And what's true about the diagonals? They bisect each other. If they bisect each other, that means they split each other in half. So this whole diagonal is split evenly in half, all right? So that must mean that this is equal to that, all right? So let's do it. Let's set it equal. 1.5x plus 2 is equal to 8. Subtract 2 from both sides. 1.5x is equal to 6. Divided by 1.5, if you do the math, that comes out to 4. Again, we're not even trying to find what the lengths are or anything else. We're just trying to find x and y. Do the same thing here. Let's just do it super quick. So this is going to be 3y plus 1 equals y plus 7. Subtract y from both sides, 2y. Subtract a 1 from both sides, that's a 6. Divide by 2. Y is 3, and there you go. There's your x and there's your y. All right? It's all coming back to you? Yeah, it's been a little while since we've done this stuff. That's why we're reviewing. All right, what about a trapezoid? What do we know about stuff in a trapezoid? Specifically angles, because they're giving you all these angles right here. All right, well, first of all, we know that you got on a trapezoid that this side and this side are parallel to each other. So parallel lines cut by a transversal. What is true about angle A and angle B? They add up to 180. Very good. Okay, they are not equal to each other. Okay, they add up to 180. So let's do that. Let's add them up and set them equal to 180. So I've got 3y minus 6. Add it to 3y. That's equal to 180 degrees. Let's add the y's together. That gives us a 6y. Let's add a 6 to both sides, which is 186. divide both sides by 6. That's a 1, that's a 3, so that's 31. So y equals 31. But on this one, it doesn't just say to solve for x and solve for y, does it? It says find each of the what? Angles. So if you want to find each of the angles, or in this one, we don't have to find them all, we just have to find one of them. So just find angle B. So here's angle B. So what do I do to solve for angle B? Plug y in for it. So it's 3 times 31 and then minus 6. What's that? 93 minus 6. What's that? 87? Is that right? Number 15, let me check. Yep, 87 degrees. So angle B is equal to 87 degrees. Find angle D. What can I do to find angle D? Do the same exact thing. All right, I'll spare you all the work. Okay, but what do? You add them up, set them equal to 180, solve for x, plug it back in, all right, and you get 112 degrees. So this would be 112. You can do the math yourself. It's exactly the same thing as we did over here, just the numbers are a little different. All right, let's keep going. 17. Trapezoid, all right? We just did a trapezoid, but we talked about the angles of it. This time we're talking about not just the sides, but what? What is this thing? You remember the name for that? It's a mid-segment, correct. All right, so that's what we learned. Remember, the mid-segment is half the sum of the two bases. All right, so if I add this and this together, then divide it by 2, then I got this. So let's see what they give you. They tell you the thing in the middle, all right? They tell you that MN is 43. And they tell you RS, this bottom one, is 54. And they want you to find PQ. We'll just call it X just to make it easy. There's a couple ways you could approach this. I'm going to show you the quickest, easiest way, I think, anyway. How far is it? Remember, this is in the middle of these two, isn't it? So it's the same distance from here as it is to here. All right, so what is the distance? How far is it from there to there? From 54 to 43, you subtract and you get 11. So what's the distance from here to here going to be then? That's going to be 11. But 11, what? Is it plus 43? No, it's going to be take it away from 43. So I'm going to go smaller, 11 smaller than 43. What does that give you? What is that? 32. And there you go. So that PQ says solve for PQ is equal to 32. Does that make sense? All right, I won't show you the other way. If you're really desperate to see it, which I don't think anybody is, you could always watch the other class's video because I do it both ways. But I'm running out of time already, so I only got 15 minutes left. So here we go. Find each of the angles in this kite. Angle A, that's easy. You can do that super quick, no math involved. Remember, a kite has exactly one pair of equal angles, and these two are the ones that are equal. All right, this is 103, that's 103 right there, piece of cake. Now, angle D, this one right here, how do I find angle D? Well, look, I got 1, 2, 3, 4 angles. What do 4 angles in a kite add up to be? Or any four-sided figure? 360. So what I'm going to do is I'm going to add these up and take it away from 360. So I got 103 and 103, which is what? 206. Add that to 124. That's 330. Okay? Is this 330? No. Okay? There's no way it can be 330. All right? But what we do is we take that 330 away from 360. So 360 minus 330 gives you 30 degrees. So this angle is 30 degrees. Is this helpful at all? Seems like I'm just teaching to 3 people. It's 4 chapters and a little bit. So it's chapters 4 and 5, 6, 7, and then a little bit from chapter 12. We only did the first 2 sections of chapter 12. Okay? So tomorrow we should, I don't think there's any way we're going to finish chapter 7 today, going over it. I only got 15 minutes left. But tomorrow we'll finish up 7, and we'll do a little bit of that trig stuff that you guys did, and then that should be perfect timing. Okay? All right, what about this thing right here? Find QS. Where's QS? Well, it goes from here to here. So that's what we got to find. And it says QV is 24. So that is 24. I don't have my sheet. I'll just put it on my desk. So QV is 24. Yes. What's that? Is it? It's not. Watch. Well, it's not necessarily 2/3. It's not always going to be 2/3. But TV, watch this. TV is 20. Okay? Now we did have a thing where this side and this side are equal to each other. All right? This TV and this SV, they're the same. So if this is 20, what's this little bit? That's 20. So now QS, that whole thing, is 24 plus 20, which is 44. Okay? So this does not bisect, because that's what you were thinking, right? You were thinking that it bisects, so if that's 24, that's 24. This is not the same as this, okay? Everybody with me on that? All right. Okay, let's go to the next chapter. So this is the most, well, not the most recent stuff, because we did the trig stuff, but this is the most recent thing that we did the whole chapter on. So let's see if we remember anything from this. Find the area. Let's make this a little smaller so I can have some room to write. We're going to find the area of a triangle. Do you remember what the formula is for area of a triangle? I'll put triangle. Tri for triangle. Remember what it is? It's base times height what? Divided by 2. All right? So I'll put that in a box because you're going to have to know your formulas for area. There's no way around it. All right? So make sure that you know those. All right, so now it's super easy. I mean, there's nothing to this if you know that formula. So if I'm going to find the area of this triangle, the base is 56 times the height is 24. And then you divide it by 2. All right, you do that math, and let me get my answer thing out. It's 672. So that would be 672. What are my units? It's centimeters, so this is going to be what for area? Centimeters squared. Area is always squared. All right? Pretty easy. Here's another formula you got to know. There's a whole bunch of stuff. Look, triangle, parallelogram, rhombus, trapezoid, kite. You're going to have to know the formulas for all of those. Fortunately, a couple of these have the same formula. And one of them, the trapezoid, is very, very similar to this one. All right? What's the area of a parallelogram? Area of a, I'll just put P. It's just simple, base times height. That's all it is. All right, so make sure you know that. We good? So let's put it in here. So area equals base times height. They tell you the base, which is 12. They tell you the height, which is 6. Do the math. That's 72. It's in feet, so it should be what? Feet squared. No brainer, right? Yeah, everybody should get those two right. Area of a rhombus is a little different. It's the diagonals, right? So the area is what? 1/2, what? D1 times D2. Okay, what is D? It's the diagonal. Okay, the diagonal is from here all the way to there. So is the diagonal equal to 4? Now this is a rhombus. What happens to the diagonals? They bisect each other. So if this is 4, then this is what? 4. Okay? If this is 3, then this is 3. You got it? So what are the diagonals? What's this diagonal? It's 8. So you're going to go 1/2 times 8 times, what's the other one? 6. If I recall, it seems like I remember people just putting 4 and 3 into this. All right, but 4 is not the entire diagonal. You got to find the whole entire thing. All right, 6/8 are 48. Half of 48 is 24. It's in inches, so it's inches squared. All right, let's go to the next one, trapezoid. Remember I said earlier, one of these formulas is very similar to one of the other ones. This is very similar to the triangle formula. What was the area of a triangle? That's it, base times height divided by 2. The problem with this is, it's not really a problem, but the deal with this is, it's got 2 bases, right? So I just add them up, right? Instead of just base times height, I add up the bases times the height. And how do I write that? Here's 1/2, and then b1 plus b2 times the height. So again, memorize that. Memorize this one as well. Okay? All right, so let's put the numbers in. So the area, let's put it right here. Area is 1/2. The 2 bases added up, right? Add up the 2 bases. Just do that in our head. What's that? 34 times the height. What's the height on this? It's 9, okay? Right there. And you throw that into a calculator, and you get 153. 153. It's in meters, so it's meters what? Squared. Area is always squared. All right. Remember what I said earlier about the area of a couple of them have the same formula? Well, here's one of those. Area of the kite. It's got the same formula as the area of a rhombus. So let's write that down again. Do you remember what the area of a rhombus was? 1/2 d1 d2. All right, so that is the area of a kite as well as the area of a rhombus. All right? This is actually a little easier because you didn't have to fill in, right, for the other diagonal. They put them both in here. So that's one diagonal, and this one across like this is another diagonal. So let's find the area. It's 1/2. This diagonal, which is how much? It's 6. Times the other diagonal, which is 8, because 2 plus 6. Same numbers as this one, right? 48, half of 48 is 24. What are your units? Centimeters squared. Excuse me. Everybody good? All right, we got up to number 9 in the last class. Let's see if we can do the same thing in here. This one you can do without doing any math at all. 7, 12, 13. It's a Pythagorean triple. It's one of those ones, if you memorize them, okay, if you recognize it at least, then you should be able to do this without any problem at all. It's not a 7, it's a what? It's a blank 12, 13. It's a 5, 12, 13 triangle, right? So you write down 5, move on to the next one. If you didn't know your Pythagorean triples, what would you have to do to solve for x? Pythagorean theorem. Okay, let's do it pretending we didn't know that was 5. All right, so what would we do? I go x squared plus 12 squared equals 13 squared. X squared plus 144 equals 169. Subtract 144 from both sides, so x squared is going to give me 25. Take the square root. Square root of 25 is 5, just like we said it was, right? But if you know your Pythagorean triples, then saves you all that work and all that time, okay? This is also a Pythagorean triple. This is a 3, 4, 5 triangle. It doesn't look like it. I don't see a 3, I don't see a 4, I don't see a 5, but it's in there. What divides evenly into both 6 and 10? No, 2 does. 2 divides into 6 3 times. 2 divides into 5 or into 10 5 times, correct? So this side is 3 times 2. This side is 5 times 2. What's this side? This would be a 4, right? But it's not, the length is not 4, it's what? 4 times 2, which is 8. And there you go. That's your answer. So if you know Pythagorean triple, it just makes life a lot easier when you're doing those kind of problems. All right, let's do number 8. Again, you could have done Pythagorean theorem, couldn't you? You could have gone a squared plus 6 squared equals 10 squared. Do all the stuff. You'd still get an 8. All right? It's up to you. Now this one, we have to do Pythagorean theorem because there is no Pythagorean triple with this. All right, this scares a lot of people off, but it really makes this problem a little bit easier, to tell you the truth. Wouldn't you agree if you got this right? So what do? We're going to take these two, square them, add them up, set them equal to this squared. So let's do the z first. So it's going to be z squared plus, it's the square root of 7 squared, and that's going to equal 7 squared. All right, watch how easy this is. That's z squared plus. Here's what I'm talking about. When you square a square root, they just cancel each other out, don't they? And what are you left with? Just a plain old 7. You see, it looks complicated when you see it at first. It's really not, because you're going to square it and get rid of that square root anyway. And that equals what? 49. Subtract 7, that's 42. Take the square root of 42. And that's how you write your answer. It says in the problem to write it as a what? An exact length. This is exact. Don't put it into a calculator and give me a decimal, because that would be an approximation. Make sense? All right, one more. Look at that. Doing pretty well. It says classify them as right, acute, or obtuse. Are you just going to take a 1 1/3 chance and just guess what it is? Even if you guessed it right, it's going to be wrong. Why? Because you didn't show your reasoning or show your work. Okay, you got to show why. Okay, you know from day one, I'm big on that, showing your work, showing how you got these answers. So what do? We take, remember this, that c squared, and we compare it to a squared plus b squared. That's what we're doing. So if this c squared was greater, it would be obtuse. If that c squared was less, it would be acute. If it was equal, it would be right. So that's what we're going to do. C is always the biggest side. So let's do that one first. Which one's the biggest one? 14. So we go 14 squared, and then we compare it. Leave a little blank. Compare it to 5 squared plus 12 squared. 14 squared is 196. This is 25. That's 144. You add them together, you get 169. What is 196 compared to 169? It's greater than, so which one of these is it going to be? It's going to be obtuse. So that's how you do that. Make sense? All right. So remind me tomorrow to start with this one, okay? And then, so you don't have to watch the other class's video or anything. We went to the same exact spot as the other guys did, all right? So, and we didn't even collect their books, so we went a lot faster in here than I went in the other class. Everybody good? All right. That's it. One more day. One more. Believe me, I wake up every morning counting down. It used to be like 3 months ago, teachers would say, oh, we only have 3 months. I'm like, don't even start the countdown, right? I started the countdown this week, all right? So I'm excited about it. I know you are too. I know this is not exactly what you want to be doing during your days, but this is good if you're taking the final. If you're taking the final exam, you should be very appreciative that we're going through as much detail as we are to prepare you for the final exam, okay? So I'll take all your thank yous and everything on the way out, okay? That's right, and we're going to be done. So you should be happy, right? We get out early. I mean, my goodness, we used to never. I mean, when I was a kid, we never got out till like the middle of June, and here it is, the middle of May, and we're almost finished. You know, so be happy about it. Be appreciative. Find the good things in life, not the negative things, and makes your life a lot better. All right, enough of that.